The Smiths have a small farm where they grow corn and tomatoes to sell. They have a total of 21 acres available for planting, and because they cannot afford to pay much for help, they have many restrictions based on their labor. They have a total of 150 hours available for planting and 130 hours available for harvesting. Each acre of corn takes 6 hours to plant and 4 hours to harvest. Each acre of tomatoes takes 10 hours to plant and 10 hours to harvest. A local grocery chain has agreed to purchase 3 acres worth of tomatoes. Let C equal the number of acres of corn planted, and T be the number of acres of tomatoes planted. So, first thing we're asked to do is write a series of inequalities that represent restrictions on this situation. So, the first one is the land available. We know that we only have a total of 21 acres that we plant, and with the definition up here, this nice let statement of T and C, we know that if we add the number of acres that we are planting with corn, right, C, plus the number of acres that we're planting with tomatoes, that has to be less than or equal to 21, right? It can't be more than 21 because that's all the acreage that they have. So this is a simple C plus T is less than or equal to 21. The next one that we have is it says time available for planting. So depending on which kind of acreage I'm planting, it says the corn takes 6 hours to plant and 4 hours to harvest. The tomatoes take 10 hours to plant and 10 hours to harvest. So tomatoes are 10 both ways. Um, so let's see here. Corn takes 6 hours to plant. So every single acre I plant of corn, it's going to take me 6 hours. So I'll say 6C, right? I'm using capital C. So every single acre takes. So if I planted 0 acres of corn, it would take no time. If I planted 2 acres of corn, it would take 12 hours, right? 6C. And then plus, the tomatoes are a little bit more time consuming. It would be 10T. So every acre I plant of tomatoes, it would take 10 hours to plant. Now, my planting time is limited to at most 150 hours, right? So this hours planting corn plus hours planting tomatoes has to be no more than 150. So this is my second restriction. A third restriction that we have involves time available for harvesting. It turns out that corn takes less time to harvest than it does to plant, so that would be 4C. Tomatoes is the same amount of time to harvest and plant. And for some reason, I have fewer hours available for harvesting. That's 130. So the time that I spend harvesting the corn plus the time that I spent harvesting the tomatoes can be no more than, it has to be less than or equal to 130 hours. And then there's one additional constraint here. This grocery chain has agreed to purchase 3 acres of tomatoes. So I know that I need to plant at least 3 acres of tomatoes because I've essentially already sold them to the grocery chain. So I'm going to say that the number of acreage of tomatoes I plant has to be at least. Whoops, let me make this equation. Sorry, T has to be at least 3, right? So 3 or more than 3. So these constraints, I'm gonna graph, and for simplicity, I'm gonna go ahead and choose an x or a y for these. So when I set this up in GeoGebra, because I want to graph it over there, I want it to be kind of easy for me to look at. So I think I'm going to go ahead and put tomatoes on my x-axis. So I'm going to just put this, let T equal the number of acres of tomatoes planted. And I'm just going to put X in there to remind me I'm going to use my X-axis for that. And the corn I'm going to place on the Y-axis, so I'll put a Y here. So I think I'm set up now to go ahead and take this information and turn it into a graph of all my constraints. Okay, so I've started kind of a standard window of GeoGebra here, and I'm going to input some things down in the input. Again, I've decided that I'm going to let the tomatoes be my x-axis, and I'm going to let corn equal the y-axis. So Yeah, I did write out my inequalities in terms of C and T, but it's easier for me to graph these things in GeoGebra because it understands the X and Y. So my first one is that my X plus Y, X plus Y has to be no more than 21. So you can see I wrote it, it's less than or equal to 21, and this is it. So everything below that line represents planting no more than 21 acres. And of course, if you think about it, for this particular constraint, it doesn't make sense to think about negative acreage. So I'm limiting it really just to this first quadrant. So all the points in here represent a valid number of acres each, right? So I could plant 5 acres I think this is tomato. We said the X was tomatoes. 5 acres of tomato, and I could do 16 acres of corn. So you can see up to 16, and that would give me 21. Now I could plant less. I don't have to plant all 21 acres, but planting the most acreage is represented by that constraint. The next constraint we had was that 6 times the acreage I plant in corn, so 6y, because I put corn was my y-axis, and then plus 10 x. So this is every single acre of corn takes 6 hours to plant, and each acre of tomatoes takes 10 hours to plant, and that has to be no more than 150 hours. So I'll add this additional constraint. So now you can see there's all of this stuff just got lopped off, right? This is no longer part of my solution, and it's just this stuff below this line and below this curve. So still in the first quadrant, but I do have some restrictions now because of this additional constraint. There's another constraint that says time available for harvesting. Remember we're letting Y be my acres of corn that I plant, and the acres of corn takes 4 hours to harvest. Each acre does. So I'll be typing 4C plus 10. Not. I gotta use X and Y. 4X. No, 4Y. Y is the corn plus 10x, and that has to be at most less than or equal to, it can be no more than 130. So there's another constraint. So again, this region in here just got chopped off. So you can see, boop, doop, doop, there's some vertices here. Final constraint that I have is that we've already sold 3 acres or grocery stores agreed to buy 3 acres of tomatoes if I plant them. So I've essentially already sold them to them. So I'm going to say that the tomatoes, which is X, has to be it has to be at least 3. So it has to be 3 or less. So you can see this is this horizontal line that is just placed in here, and I'll just press enter there. So everything in this darkest region now represents all of the constraints that I can plant. Again, X is the tomatoes and Y is the corn. So all of these values I could plant, any one of these, and that would satisfy all the constraints I have. Now, if I'm interested in maximizing my profit, right, I'm going to be looking at different vertices that I have here. So I can see quite a few vertices. In fact, let me I'm going to grab all of those and kind of play with the shading a little bit because I feel like it's kind of hard to see. But maybe I'll go to a grayscale. Yeah. Anyways, I'm going to leave it at grayscale. So this region in here that's the darkest of them is all of them overlapped, and that's the one we're looking at. Now, identifying these vertices is kind of important. So for example, I can see X is, what is it, 1, 2, X is 3, and Y is 18. So 318 looks like an important vertex. And you can see when I graph it, yeah, I placed the plot point right there. So that's definitely one of the points I want to consider. Another one is right here when X is 6 and Y is 15. So let's look at that one. 6 comma 15, and that's great. Another one that I have is right here, where x is, I believe, 9 and y is 10. So I'll look at 9 comma 10. Then there's a couple more constraints if I look at the whole region, right? I guess I could look at, what is this, 10, 11, 13, 13, 0. So x is 13, y is 0. And then the final constraint I'll look at is when x is 3 and y is 0. So those are the vertices of this polygon that is basically the boundary of the area that satisfies all inequalities, right? This is, in here I'm satisfying inequalities D, A, B, and C. A, B, C, and D. And I can drag those out here. Here's the inequality A. Here's the inequality B, right? Here's the inequality C. And then here's the inequality D. And when we look at these, we can see that this was the one based on acreage I have that I can plant. This is the one based on the amount of time that I have that I can spend planting, amount of time I can spend harvesting, and the fact that I've already sold 3 acres of tomatoes to the grocery chain. So what I have now is, it's nice when I'm moving around and I hover in a particular spot. GeoGebra is telling me the spot that applies there. So now that I'm doing it, it's nice. Yeah. So this is they're all good there. Here you can see only 3 are true. Right here there's just the 2. Here just 1. That's that one where I've sold 3 acres. So all this represents that 1. This one right here, that's interesting. Oh no, there's just the 3. So there's this little region in here where there's just the 3. Also, I can zoom in a lot. You can see right here only 3 of the inequalities are satisfied, but here all constraints are. So what's nice is I can look at this and I can say, the spots where all the constraints are satisfied, and you can see exactly it's exactly in here. All 4 are satisfied, and then the vertices of this area is basically what tells me where I'm going to look for my optimization values. And the other piece of information that we were given was that when I'm ready to sell what I've produced, each acre of corn can be sold for $600, and each acre of tomatoes can be sold for $800. So the question is, where am I going to get the most money from selling what I've produced? Again, remember, these are the x-axis here are my tomatoes, and the y-axis is corn. So I'm going to try something in GeoGebra just because I think it's super cool. I know that right now the number of acres of tomato I plant is the x-coordinate of a point, and you can see I've added some new point here, F, and I can move F around and I can easily snap it to the lattice. So this is right now 6 acres of tomatoes and 10 acres of corn. I want to write a function that'll calculate the profit based on the information they give me in part C. So what I'm going to do is I'm going to extract the x coordinate and the y coordinate from point F and use that to define carrots and tomatoes. So for example, I'm going to say capital T, which is the acreage I'm going to plant in tomatoes, is equal to, and I just want to get the the x value from point capital F. So that's the syntax, right? I'm going to define a variable at t is going to equal the x value from coordinate F, and when I press enter, you can see t is currently 6. And yeah, if I look at this, the F value here is 6. So I've got 6 acres of tomatoes. Then I can do the same thing with corn. I'm going to say the acreage I plant in corn is the y value read from point F also. And there so I've got now corn and I've got tomatoes. Now, what I'm going to do is I'm going to try and define another variable, PRO, profit. I'm going to say profit is going to equal, or I guess I don't think it's profit because I don't think it includes other expenses. I'm just going to call it income. and that's going to equal $600 for every single acre of corn. So I'm going to say $600 times C, that's a capital C, yep, plus $800 and a capital times capital T, and I'll press enter there. So right now I can drag this expression income over here so I can track it more closely, but it's telling me the income from this particular point that I'm at. So what's nice about this is you can see if I come down here and I plant nothing, right? I plant no corn, I plant no tomatoes. Whoops, I got to get it to snap at the origin. Oh, it's not snapping there. That's close enough. You can see I've got an income of nothing. Now, if I plant 1 acre of tomatoes, is $800. 2 acres is 1,600, and then here's 3 acres at 2,400. So there are certain things I can't do. For example, I can't come way over here to 25 because I don't even own 25 acres, and you can see that that exceeds some of my planting and harvesting constraints. So if I stay in the constrained area, I want you to notice that right here at point D, I've got $10,400 as my income. Up here at point B, I'm at 13,800. At point C, or right up here, I'm at $13,200. And way down here, this is, $2,400. So if I look at it, I can move around in here on a lot of places, but I want you to notice that I could be all in here, but when I land at B, that's the, boom, largest number I get. In fact, anything else up here is smaller, right? That's 13,400. This is 13,600. Here's 13,800. Now, if I could stay on that curve, I go to 14,000, 14,200. But the problem is I can't stay on this curve because some of my constraints aren't being met. And I notice that I'm missing a point, right? There should be another point right here. Let me add that back in. That was the point when x is equal to, I think it's 9, and y was equal to 10. Let me enter that. Yeah, there we go. And now it's a different color from the other ones. That's going to bother me, so I'll just come up here and I'll just set the color to this same blue one. There we go. So this is a possible point, right? But you can see right there, that's 13,200. So the place where I'm getting the maximum profit is $13,800. And again, I was able to set this up so anything inside of here, all of my constraints are satisfied, right? And you can see that I'm extracting this t is defined to be the it's the y value at point F. This right here is defined to be the x value from point F, and here's point F. And then the income, if you'll recall, it was 600 times the acreage planted in corn plus 800 times the acreage planted in tomatoes. So it's just a really cool visual way to see, oh my gosh, yeah, at the vertice, I'm maximizing values right here. And if I land up here, it's less, right? The most I can get is right here, $13,800. It goes down here. It's interesting, there's some symmetry. This is 13,200 and this is 13,200. Way down here I'm just at 10,400, and over here I'm at $2,400. So anywhere in here meets all of our constraints, and only at the vertices do we get, at this particular vertice, do we get our maximal values. So when the question asks how many acres of each type should the Smiths plant, the answer should be they should be planting 15 acres of corn and 6 acres of tomatoes, or in this case it would be 6 comma 15. And then finally this other question was the Smiths neighbors have 2 acres available for lease of $1,000. Should the Smiths lease the additional land? Hint, have one person from your team draw in this adjusted available land instead of 21 acres. Um, so if I was going to add that constraint, I notice what happens here. So what we're going to say here is it's the x plus y, right? It can now go up to 23 acres because I had 21, so I could say is less than or equal to 23 acres. And when I add that, notice that it doesn't change anything, right? Because it's out here parallel to the lands I had before. All of my points are still here, right? When I'm overlapping all these values. So this is the only spot. These are the only spots inside of here that are meeting all of the inequalities. So when I'm right here, oh dear, I didn't want to move that point. I want to leave that one there. But you can see when I'm here, all of my inequalities, including this new one that gives me 2 more acres of land, are being met. But it didn't change where these particular points were. So I would say no. Now, if all of a sudden I had more time to plant and more time to harvest, that might be more interesting because it would change these other two curves. But without changing these other curves, um, we're still going to have the exact same solution. So anyways, I realize this is a little long and probably more than you want, but I just think using something like GeoGebra really helps us visualize exactly what's going on, and it makes it a lot more, I don't know, accessible and applicable to perhaps the real world.